Hello students, today we will study the question number 7 of exercise 6.1. This is the topic of standard 10 chapter number 6 triangles. So what is the question? Question is prove that the area of an equilateral triangle described on one side of a square is equal to half the area of the equilateral triangle described on one of its diagonal. One of its diagonal means one of the diagonal of square. So here first of all we have drawn one of the square, that is A, B, C and D, right? By taking the side AB, we are extending this, describing one of the equilateral triangle. So one of the equilateral triangle we have drawn here is triangle PAB. So we can say that this side PA will become equal to AB and will become equal to PB, right? So one of the triangle we have described on one side of the square. Another triangle we have to describe by taking the diagonal of the square. So here we have considered AC as a diagonal. So this AC will become one of the side of the equilateral triangle. So another side will be QC and third side will be AQ. So here two triangles are there, PAB. It is an equilateral triangle. In the same way, QAC, it is also an equilateral triangle. We know that equilateral triangles have all their sides are equal, right? Okay, and what we have to prove? We have to prove that the triangle described on the one side of a triangle, the area of this triangle is half the area of the triangle described on the diagonal of this square. That means area of PAB is the half of area of QAC. This we have to prove, right? Understand? So this is the diagram that we have drawn from the question, and this is we have to prove, right? Okay, now let us start from we know that this triangle PAB is equilateral triangle, so all of its angles are of 60 degree. Okay, in the same way QAC is also an equilateral triangle, so all of its angles are also of 60 degree. So let us write down that triangle PAB is equilateral triangle, so that we can write down that angle A is equals to angle B is equals to angle P, and that will become equal to 60 degree. All these angles are of 60 degree, right? Give it the equation number 1. In the same way, QAC is also an equilateral triangle. So triangle QAC is also equilateral triangle. So that we can write down that angle A is equals to angle Q is equals to angle C is equals to 60 degree, right? Give it the equation number 2. So we know that we can prove this area of PAB is half the area of QAC by taking the ratio of the area of this two triangle. And whenever we have to use the ratio of the area of the two triangles, we have to prove that the two triangles are similar. Now see, in all these two triangles, both these all the three angles are equal. So here we can say that the triangle PAB, it has all these angles are 60 degree, and the triangle QAC, all the angles are also 60 degree. So from equation number 1 and 2, what we can say that? We can say that triangle PAB is similar to triangle QAC by angle rule, right? because all the three angles of both this triangle are of 60 degree, and also we can say that all the equilateral triangles are similar to each other. So here both this triangle PAB and QAC are equilateral triangles, so they will become similar to each other by angle rule. So now as these two triangles are similar, we can write down the ratio of their areas as area of triangle PAB upon area of triangle QAC, and what we can write down, it will be equal to PA upon QA whole square. It is also equal to AB upon AC whole square, and it is also equal to PB upon QC whole square. That is the ratio of the square of the corresponding sides, that we can write down according to the theorem number 6.6. right? Now see, let us consider the triangle ABC. Here we know that the angle B is of 90 degree, because what is ABCD? ABCD is a square, so all its angles are of 90 degree. So here we can consider triangle ABC, and that is angle B is equal to 90 degree. Why we are considering triangle ABC? Because see, one of the relation here we have find out between the AB and AC sides. And which triangle consider AB and BC side? The triangle ABC consider the sides AB and BC, so that we can find out the relation between AB and AC. That is why we are considering triangle ABC. So it is 90 degree. So according to the Pythagoras rule, what we can write down, that AC square is equals to AB square plus BC square, right? This we can write down according to the Pythagoras rule. Now what about AB and BC? What about AB and BC? We know that ABCD is an equilateral triangle, so we can write down that side AB is equals to side BC, right? Equal sides, because ABCD is a square. So now instead of BC, what we can write down? AB, right? So we can write down that AC square is equals to AB square. AB square will remain as it is. Instead of BC, now we can write down AB. So AB square plus AB square, that is 2 times AB square. So AC square is equals to 2 times AB square. Now see what the ratio we required, AB upon AC. So take this AC to the right hand side and 2 to the left hand side. We get 1/2 is equals to AB square upon AC square. Also we can write down it as a AB upon AC whole square is equals to 1/2. Right? So now what we have to do? We have to compare. Okay, give it here. This is the equation number 3. Right? And this is equation number 4. So when we compare both these equation number 3 and 4, right? When we compare both these equation, here instead of AB upon AC square, we can write down 1/2. So left hand side we have is area of PAB upon area of QAC, and that will be equal to, instead of this, now we can write down 1/2, right? So by taking to the right hand side, we get the area of PAB is equals to 1/2 area of QAC, right? And this is what we have to prove, that area of PAB is equals to half the area of QAC, right? So this is how we can solve this type of questions. Okay, so this is all about this lecture. Thank you.